Good morning or good afternoon, depending on which class you're in. We're going to continue talking about quadratic functions and parabolas today, and we're going to talk about a little bit better way of graphing them than we did yesterday, because that doing it with a table and plugging in numbers is a little bit of a pain in the butt when there are definitely some shortcuts. All right, so first off, let's look at the function itself, the quadratic function. F of x equals ax squared plus bx plus c. Right? That is something we want to be aware of. We want to know where the a, b, and c numbers come from because we're going to be using them in these shortcuts. So first off, if the a number is greater than 0, meaning it's positive, then the parabola opens up, kind of like positive slope goes in the up direction. And then if the a number is less than 0, or it's negative, the parabola opens downward, kind of like, again, negative slope would be pointing in the down direction. All right, then the axis of symmetry, and again, if you don't remember what that is, the axis of symmetry is that dashed line or imaginary line runs right through the middle of the picture, folded up on both sides, and they would match. Well, that axis of symmetry has this, the coordinates x equals negative b over 2a. So again, you have to know what a and b are to be able to do this. But again, it tells us exactly where that axis of symmetry will lie. Then is the vertex. That's that corner point on the graph, right on the axis of symmetry. And to do that, we're going to substitute the x value that we just got from step 3 into the function, and that'll find the y. And that y-coordinate will tell us where on the axis of symmetry the vertex is, because the vertex is always on the axis of symmetry somewhere. All right. Then the fifth thing we need is another point. So the easiest one to find is the y-intercept, because it is the c number. You don't have to do any work to find it. It's just there. But if for some reason that c number is not graphable, meaning that it's either a weird fraction or decimal, or it's a number that doesn't fit on the graph, like 97 or something like that, then we just want to find any point near the vertex. And I'll show you how to do that in one of our examples today. And then last, we want to find the mirror image of whatever point we just got from step 5, whether that was the easy point, the y-intercept, or if we had to find ourselves a rather random point. We want to find its mirror image, exactly the same distance away on the other side of the axis of symmetry, and that will be all we need for our graph. So let's go ahead and try a couple of these. All right, first one here. Got a function y equals, or f of x equals x squared minus 3x minus 2. All right, so in this one, first thing we want to do is we want to identify what our a, b, and c are. So in this problem, well, that's a little thicker than I wanted it to be. We want the a, which is the number in front of the x squared, which is a 1. We don't see it, but it's there. My b number is the one in front of the plane x. That's the negative 3. And my c number is out in the back, the constant term, negative 2. All right? So now let's find some of these pieces. All right? So first off, since the a is positive, I know that whenever I draw this graph, it's going to open in the up direction. All right? So let's go follow the order that's on here now. The axis is the first thing we're going to find. And to find that, we want x equals negative b. Well, b is negative 3, so I want the negative of negative 3 all over 2a. So 2 times a, which was 1. So the numerator, the negative of negative 3 is 3. So it's always the opposite. If b is a negative, then this is a positive. If b was positive, then that number would be negative. And then the denominator, 2 times 1 makes 2. So my axis of symmetry is at 1.5. So if I go over here to my graph, right about at 1.5, that's where I'm going to draw in my axis of symmetry. Doesn't have to be perfect. All right, again, I'm not going to be too picky on these, especially when you're graphing on a computer. Just do your best. All right, next I want to find is the vertex. Now the vertex is an actual ordered pair, coordinates. And I just found the x-coordinate, the 1.5. So to find the other part of that coordinate, what I'm going to do is evaluate this function at 1.5. So that means 1.5 squared minus 3 times 1.5, and then minus 2. And again, I got a calculator for that. So my vertex has an x-coordinate of 1.5, and then if I do that all on my calculator, I end up with negative 4.25. So that means on that line I just drew here, just down past negative 4, that's where my vertex is. And again, don't worry about the decimals. I'm not going to be too picky about the graphs. As long as you're anywhere close, I am good. All right? And then lastly, if the y-intercept is there, then this is great. And the y-intercept is this C number. So that means there should be a y-intercept at 0, -2, which clearly fits on this graph. All right, now the only step that's not listed here is finding the mirror image for that point. That point looks to be 1.5 spaces away from the axis of symmetry. So go 1.5 spaces on the other side, and you've got its mirror image. Now you can draw the left and right side of your parabola. Double check. Back at the beginning we said it was going to open up, and it does. All right, so it's a good idea that we've drawn this correctly. All right, let's try one more. Let's make it one where it doesn't quite work out so nice for the y-intercept. All right, we're still going to follow the same procedures though. My A, which is -1/2. My B is 4. My C is -8. All right, because my A is negative, this graph will open pointing downward. All right, now let's go find the axis of symmetry. So to find the axis of symmetry, I want the negative of B. B was 4. All over 2 times A, which was -1/2. So numerator is -4. Again, like I said earlier, it's always the opposite of what B actually is. And then denominator, that would be 2 times -1/2, which would make -1. And then all equals 4. That means my axis of symmetry is over here at 4. All right. Now that axis of symmetry number I just found is also half of the vertex. The vertex is somewhere on that dashed red line I just drew. To find where, I'm going to plug the 4 into the actual function. So that means -1/2 times 4 squared plus 4 times 4 minus 8. And again, I would do that on a calculator if I was you. And if you do all of that on a calculator, you end up with 0. So that means my vertex is at 4, 0. So right there on the x-axis. That's where the vertex was for this one. And then last but not least, the y-intercept. Again, that's the C number. So I should have a y-intercept at 0, -8, which would be down in this zone somewhere. Which, to be honest, I'd be completely okay if you did the graph that way, and then found its mirror image over here on the other side, which again would just be eyeballing it. You wouldn't be 100% sure, but you know what? It'd be good enough for a sketch, and that's what this is. All right, but for those of you that want a little more perfection, all right, what we're going to do next is instead of that, what we want to do is we want to pick an area or pick a number for x, plug it into the problem, and just find another random answer. We can pick any number we want for x. We can pick -6, we can pick 1, we can pick 2, we can pick 7. Just pick something close to where the axis of symmetry is. Pick something close to 4, like 2 or 3 or 5 or 6. I mean, you can see that the graph's going to look something like this. All right, so you can tell where the numbers are going to be at this point. But I'll go ahead and pick something that's close. I'm going to go ahead and pick x equals 2. So that means I'm going to do -1/2 times 2 squared plus 4 times 2 minus 8. Again, if you're wondering where I'm getting that from, it's right here. I'm just plugging a 2 in where the x is. And if I do all of that, I end up with -2. So I plugged a 2 in, I got a -2 out as my answer. So I could go to 2, -2 on my graph. That would make it easier to find its mirror image 2 spaces away on the other side. And again, you can now see, oops, I missed the dot, but that's okay. You can now see my graph. And I won't be upset with you if you miss your dots or if your lines are crooked or, again, I'm looking for a sketch. A sketch means it's really reasonably close to being perfect, but it's not perfect. The dashed line's not perfect. The line's crooked. The dots are in the wrong spot. That's all okay. All right, let me know if you need any help. Good luck.